All right, in this video, I'm going to go through the 6 problems under the heading Verifying Trig Identities number 1. Each of these pages, for the most part, has a combination of verifying and simplifying. I'm going to do the verifying in the videos. And the simplifying, I'll put the key up. If you have questions or concerns, please make sure you're asking. Okay. Now, what does it mean to verify an identity or verify an equation? I'm going to zoom in on just number 1 here, so we're just focused on that one. What I want to do is pick one side of this equation, just one side, and convert it to the other. So I'm not going to, and in this case for problem number 1, I am just going to focus on changing and simplifying the left side of this equation until I can turn it into 1. And what will end up happening here is I'm going to get a statement that says 1 is equal to 1. Now, that's not, the answer is not going to be the important part. It's going to be your work along the way to show the steps. No steps, no work, no credit. Just being honest. So this is where we're going to use a lot of the same techniques that we used with simplifying. So I'm going to go ahead and take sine and cosecant and try to rewrite it in sines and cosines. So sine theta stays sine of theta. Cosecant of theta is really equal to 1 over sine theta. And I'm not even going to worry about this other half of the equation. I'll get there, but just not yet. So what can happen here is this sine theta and this sine theta can completely divide each other out. And so I'm left on the left side with 1. Well, that's what the right side is equal to. So there's the part where I'm verifying that this side on the left turned into the right side. I don't bother boxing up anything with a verify equation because all of the steps along the way are what I'm looking for, not just the end answer of 1 is equal to 1. Okay, so that's how you verify an equation. Now, not all of them are going to be that easy. So let's go ahead and see some more examples here. All right, problem number 2. I'm going to go ahead and, in this case, I'm going to multiply. All right, I've got this factor times this factor. So let's go ahead and distribute it. So 1 times 1 is 1. 1 times negative sine of theta would be negative sine theta. Sine theta times 1, so plus sine theta. And then sine theta times negative sine theta. So negative sine squared theta. So minus sine theta and a plus sine theta will cancel. And so I get 1 minus sine squared theta. If I remember my Pythagorean identities, 1 minus sine squared theta is cosine squared theta, which is exactly what I wanted to end up with. While you're working through this on the left side, always keep in mind, or whichever side, you don't have to pick the left side. In this case, it was just the easier of the two. Always keep in mind what your end goal is here. This is where I find verifying actually easier than simplifying. I know what I'm supposed to create. These are not going to be problems where you have to guess, are they equal? No, they are equal. You just have to show me how to get from one side to the other. All right, problem number 3 here. Ooh, this is a little bit of a mess, but I think I can deal with it. So I'm going to leave cotangent squared theta as cotangent squared theta because I'm pretty sure I can replace this with one of the Pythagorean identities. So secant squared theta minus 1 is really tangent squared theta. So cotangent squared theta I can replace with cosine squared theta over sine squared theta. And then tangent squared theta can be replaced with sine squared theta over cosine squared theta. So the cosine squareds will divide each other out. The sine squared theta will divide each other out. So what's left is 1 is equal to 1. Again, make sure that you're showing your steps here. There are other ways to verify this. So when you do these problems, it's not just going to be a one and done. There's multiple ways to solve these. This just is one that came to my head when I was doing number 3. All right, let me go ahead and slide over to number 4 here. All right. Let's see, cosine, okay, so this is a place where I want to pay attention to what I'm going to aim for. I almost always will try to adjust the left side to turn into the right side. You don't have to, you could make the right side become the left. But if I do convert this left side to the right side, I know I need to leave sign alone. In fact, I need to create somehow another negative sign. So let me see if I can replace this cosine squared with something. So cosine squared can be replaced with 1 minus sine squared theta. That's one of your Pythagorean identities. And then if I look at my like terms here, I've got 1 minus, well, I have 2 negative sine squared thetas. So minus 2 sine squared theta is 1 minus 2 sine squared theta. Look, they became the same thing. And again, that's the whole point of doing the verifying here. You're showing me that one side of the equation becomes the other, but make sure I can see your steps. Let's see. Number 5 is actually very similar to number 4. In this case, though, instead of changing cosine into sine, because I want to end up with cosines, I'm going to convert my sine into some cosines. So cosine squared theta minus, now I want to be careful because this negative is going to apply to this whole sine squared term. So 1 minus cosine squared theta. So distribute where appropriate. Combine like terms where appropriate. So I have 2 of the cosine squared theta is minus 1, and that's exactly what I was trying to end up with on the right side. All right, one more question here for this set. Let's see, tangent squared theta plus 4 is equal to secant squared theta plus 3. You could change either side. In this case, I'm actually going to change the right side to become the left side. So secant squared theta, I can replace this with tangent squared theta plus 1. And then there's that plus 3. Well, that's going to become tangent squared theta plus 4, which is exactly what the left side of the problem looked like. Now, you could change the left side into the right side. It won't matter in these problems which order you do them or which side you pick, as long as you can convert one side to showing what the other side looks like. What you can't do is change both sides. So this is not a place where you're going to like subtract 3 from here and subtract 3 from here. That is not how you verify. Leave one side completely alone, and you are only manipulating the other side of the equation. All right, so just keep that in mind. I'm going to go ahead and cut this video off. So this was the